So 8.8 improper integrals. And so here's the details for how to handle infinite integrals. So if f is continuous, on the interval a to infinity, then the integral from a to infinity of f of x dx would equal to the limit as b approaches infinity. So you can't have infinity in the uh, integral, so you have to relabel it. So this is more of a notation kind of thing. So as the limit as b goes to infinity, so the integral is now a to b. So you replace b with the infinite limit. Okay. All right. Number 2. If f is continuous, on the interval negative infinity to b, then the integral of negative infinity to b of f of x dx is equal to the limit as a approaches negative infinity of the integral a to b. So you just replace the negative infinity with a. That's all. Now, if you have a integral that's going to infinity in both directions, negative and positive, so if f is continuous, on the interval negative infinity to infinity, then you will have to rewrite it this way. Let me see. Yeah, this will be better. Negative infinity to some number c, and then you go add the rest of the integral from c to infinity. So you kind of break it into two parts. So then you will apply the rule that we just mentioned up here on 1 and 2 to both of these. So where c is a real number. Okay. Let's do a few examples. Chapter 8.8 is pretty chill, I think. So basically, it can be any integral that you've seen already. So something basic like this. Example 1. integral from 1 to infinity of 1 over x to the 5th dx. So you have to rewrite this as the limit as b approaches infinity of the integral from 1 to b, 1 over x to the 5th dx. So do your integral here, you're going to get this equal to the limit. So the limit stays until you evaluate the integral. So that would be what? Negative 1 over 4x to the 4th. Let me fix that. Negative 1. There we go. From 1 to b. So see how it's the same thing, you just have to deal with this notation. So make sure you use a notation, or if you see a problem like this on a test, you will get it wrong if you forget. So plug in the b, so that'll be negative 1 over 4b to the 5th, right? Minus 1 over 4 negative 1 to the 5th. So when you take the limit, this will go to 0, right? So this will equal to 1/4. Let me double check my work. I think I may have made a mistake. No, we're good. We're good. All right, so when you find a finite number like this, right, this means the integral converged to this. Are there any questions on this idea? All right, let's keep going. Let's do a couple examples and then we'll move on. So let's do one where it does not converge. Okay, so the integral, I think that's, 1 second. Yeah, that's fine. Integral from negative infinity to 0 of x e to the negative x dx. So we can tell that's going to be a product, integration by parts, right? So we need to rewrite this using the limit notation. So the limit, as I believe the note said to use a, approaches negative infinity of the integral a to 0 of x e to the negative x dx. So we're going to let u equal x, dv equal e to the negative x. I can't see that very well. Let me rewrite that. So let u equal, we said x, dv equal e to the negative x, du will be dx, v will be negative e to the negative x, right? So the formula will be integral of u dv is equal to u times v minus the integral of v du. So this would be equal to, make a little space here. So the limit as a approaches negative infinity of a to 0 of x times e to negative x is equal to x times negative e, so that'll be this, minus the integral of v du. So that will be negative x e negative x. So I've got to write my limit, I said, but technically. I should technically still have my limit here, but it's okay. Let's make this a little better. So I'm going to try to write it for every line at least, so it's not improper. So it'll be negative x e negative x minus e to negative x from a to 0, which will be the limit as a approaches negative infinity of 0 times e to the negative 0, which is just 0, right? Minus e to the 0. So all this minus negative a times e to the negative a minus e to the negative a. Right. Okay. So this is 0, that little piece right there. This is a 1, negative 1 technically. So we have the limit as a approaches negative infinity of negative 1 plus a times e to the negative a plus e to the negative a. All right, so now I got to take the limit. So what's going to happen, you go approach negative infinity, but you have a negative exponent. If that's weird, let me write one more step. Be negative 1 plus a over e to the a plus 1 over e to the a. This is going to have division by 0, right? So this will become infinite. The limit will be infinite, meaning it diverges. So this is basically saying negative 1 plus this, right? Still infinite. This integral diverges. Any questions on number 3 or chapter 8.8? Does that make sense? All right, so let's start the reviewing. The exam will probably be next Tuesday, 13th.
Wait,
Uh,
Professor, why would a over e to the a equal positive infinity?
so this goes to 0, this fraction. So it's basically saying 1 over 0 here. Let me show you. So I guess picture this. This is a fraction, right?
Hmm.
So this is becoming even though it's negative, it's becoming incredibly large. So this bottom part becomes 0 because of that. So
Okay,
whenever you have division by 0, it's basically an infinite idea.
okay.
So the limit becomes infinite.
All right, thank you.
Yeah. If you were to graph it, you would see it. You would see it as well. Okay. Okay. So this is exam 3 review. Oh, excuse me. I'm sorry. All right, so number 1 is the integral of 2x over the square root of x minus 4 dx. So how should we integrate this? Because I'm not going to tell you what technique. The exam is going to just ask you to integrate. So it's not by parts. It is not a trig sub. It's not a basic power rule. Most likely, it should be a u sub. So I'm going to try u, see if it works. X minus 4, dx is equal to, sorry, du is equal to dx, right? But what is x equal to? Solve for x. X would be equal to u plus 4, right? So you can replace this x and this x minus 4 at the same time. So this will become, I'm going to pull, the 2 doesn't really do anything, so I'm just going to pull it out in front. The x becomes u plus 4 over the square root of u du. Do you see, does that make sense? One second. All right, so let's just integrate this guy here. I can separate this into two integrals. The 2 are just going to be chilling out here, not worry about it. So it'll be the integral of u over u to the 1/2. I'm going to go ahead and change that square root, plus the integral of 4 over u to the 1/2. So this one is just a pure substitution. It was just maybe more of a clever or difficult type of sub. This division, though, becomes the integral of u to the 1/2, right? You subtract those. That 4 doesn't do anything. I'm going to go ahead and pull it out and bring that u up top. Forgot my du over here. All right, so integrate that guy. So that'll be 3/2. That'll be 2/3 times u to the 3/2 plus 4 times 2 over 1 times u to the 1/2 plus c, technically. All right, so we can bring back what u actually is, and we're pretty much done. So this would be 2 times 2/3. Sorry, x minus 4 to the 3/2 plus 8 times x minus 4 to the 1/2 plus c. Now they both have a 1/2 power in common, so I can pull that in front and multiply this 2 out, I guess. I can also pull out 2 from these guys, which would be like I pulled out a 4. So this would be equal to 4 times x minus 4 to the 1/2. So I'm factoring that out of everything, which would leave me with a 1/3 x minus 4. So I factor out 1/2, that leaves 2/2, which is 1 plus 8 plus c. Let's see if that's what they got. Oh, shoot. Well, yeah, that's what they got, but they did some more algebra. They went ahead and multiplied this stuff out. 1/3 was here. I guess I'll go ahead and go further. If I factor out 1/3 from both, Do you agree that it would become this? Hold up. I feel like I missed. I feel like I missed something. If I integrate this guy, add 1 becomes 1/2. Divide by 1/2 is the same as 2. Add 1 gives you 3/2. Divided by 3/2 is 2/3. The x minus 4 was here and there. Pulled out 1/2 of them, which left me with 1 and none. The 8 is cool. Oh, I see where I went wrong. I pulled out a 2 from everything, right? So this should be, this number's wrong right there. Sorry about that. If I factored 2 more from both, making this a 4, this becomes a 4. If I factor a third from both, this becomes a 12, which finally gives us their answer. Of course, we were right a long time ago. It's just they did a little extra algebra to get the answer choice. And that's what they got here. They left it as square root. I put a half. Is there any questions with problem 1? Okay, let's go to the next one then. Okay, let's go ahead and do, I guess, the second one here. See what's going on there. And then we'll move on to something else. All right, so let's see. Looks like there's going to be another U sub. Might be able to separate this as two fractions, or maybe I can do it like I did the last problem. Let's see. Let's try letting the bottom part equal U. Equal to U. Du will be dx. If I solve for x, it would be U minus 2. Actually, yeah, that would just end up with a similar question. So yeah, I got to separate the fractions. This would be x over x plus 2 dx plus 10 over x plus 2 dx. This is the best approach. This guy will be helpful using this. So this would be equal to u minus 2, right? So if I do the sub for this first one, you'll get u minus 2 over u du. This one will be a simple ln, right? 10 ln of x plus 2. So that one's no big deal. This guy, though, I got to separate the fractions again. So that would be integral of u over u minus du minus the integral of 2 over u du plus this answer, 10 ln x plus 2. So this becomes a 1, so that answer is just u. This is another ln, so it'd be minus ln 2 ln of u plus 10 ln of x plus 2 plus c. Bring back all the u's, that would be x plus 2 minus 2 ln of x plus 2 plus 10 ln of x plus 2 plus c. These will combine, right? Giving you x plus 2 plus 8 ln of x plus 2 plus c. Is there any steps or ideas that don't make sense? Okay. Let's move on to the next question then. This guy is just, well, we already did something similar. So let's look at, this is by parts, so we can do that guy. This is also by parts, except it'll be done twice. So I'm going to do this one. I recommend you do this using the tabular method or do by parts 2 times. Either way, using the regular, the regular formula, excuse me. Okay, so this is number, so 1, 2, 3, 4, 4. So let u. So you remember you had to choose the u, and we said we should usually pick something that we know is gonna disappear with enough derivatives. So I'm gonna let u be the derivative part for the x. Dv will be the sine because it's by default. Integrate to find the sine, or the v. That would be equal to negative cosine x. Derivative to find dx. 14 I'm just going to leave outside. X sine x dx is equal to 4 times, so the formula is u times v. I'm going to put brackets on the 4. U times v would be negative x cosine x minus the integral of v du. So me minus be a plus. So that'll be 4 times negative x cosine x plus the integral of cosine would be sine plus c. So my final answer will be negative 4x cosine x plus 4 sine x plus c. It's not too bad, right? Any questions on number 4? Okay. Let's find. So the next couple are just by parts. So I'm going to move on to something else. And if you have questions, we can do some next time. Let's do sine. I don't know what number this is. So 4 was the 5, 6, 7. So let's do 7. Okay, here it is. Integral from 0 to pi thirds of sine cubed 3x dx. All right, so there's a cube on there. So I'm going to try to do stuff from the trig section where we had to break off a sine in order to create a u du situation using our trig identities. I'm not going to write the bounds because it's annoying. Just pretend they're there the whole time. So I'm going to, let's see here, break off a sine squared and leave this guy over here. Then I'm going to apply, oops, that should be 3x. So sine squared is equal to 1 1 minus cosine squared 3x minus, actually, it's times, not minus, times sine of 3x dx. So let u equal cosine of 3x. Du will be negative 3 sine of 3x, right? So now the u goes here, du is right there. So I need to solve for dx, right? I need to put the minus over here. So negative du is equal to 3 sine 3x dx. So this becomes 1 minus u squared. Oops, there's no 3 either, so I gotta divide the 3. Times du over 3. Okay, pull out the negative 1/3. So now I have 1 minus u squared du. Okay, integrate this will be pretty easy, right? So that will be u minus u cubed over 3. And then I got to put my bounds, right? The bounds were 0 to pi thirds, but I need to switch it back. So that will be negative 1/3. U is cosine 3x minus cosine cubed 3x over 3 from 0 to pi over 3, which will be negative 1/3 times, plug in pi over 3, that'll be, yeah, I don't think I have space, but I think you guys know how to plug in numbers. The eventual answer will be 4 over 9. Anyway, any questions about the substitution or the identity part? All right, number 8 is similar. It's a little bit more complicated. Let's see here. 9 and 10 are similar. Let's see. 11 it changes to doing inverse trig functions. So the integral from 0 to 1 of dx over the square root of 81 minus x squared. So this looks like it's going to be a sine inverse, right? So this is no real big deal here. So this will be dx over the square root of, so it helps to rewrite this guy, but you don't have to if you're comfortable with this already. So the answer using our formula will basically be sine inverse of, crap, let me look at the formula. I think it's a over x, or, yeah, let me check. Where's my formula? Now here it is. So the integral will be arc sine of u over a. So ru is x. So it'll be x over 9 plus c, which is equal to, oh, actually, from 0 to 1, my bad. Which would be arc sine of 1/9 minus arc sine of 0. Arc sine of 0 would be 0. So this would be our answer.
For the test, are we gonna have to have all the like the arc sine integral memorized and all that?
Well, you can have one page front and back of some whatever you like, formulas, definitions, that type of stuff.
Oh, okay.
Just not examples or anything.
All right, awesome. Thank you.
One second. Okay. I guess well, let me see if it's a good stopping point or not. Uh, okay. Yeah, so let me show you these. So the next, so number 12, 13 are all about inverse trig. Then after that, we get to partial fractions, which you can do a few of those. And then at the end it's going to be um, improper integrals. There. Okay, yeah. So we'll stop here, and so next time we'll go over more. Well, what I want you to do is go over the review and see if there's some that you get stuck on, and if not, I'm going to try to do one or two of each type of question. So if you don't have any questions next time, I'm just going to keep going from where we left off. Okay. You got any questions from any of the problems so far, or any issues on your homework?
I have a question, sir.
Yeah.
When is this test that's gonna come up?
It's going to be on Tuesday, a week from today.
Okay.
So at the earliest. So I'm thinking we'll review today, review Thursday a little bit, answer homework questions, and then next Tuesday. So we'll see how things are on Thursday. But if we're so yeah, I'll unlock the test probably tomorrow, but it won't close till Tuesday of April 13th. But if you guys need more time, I can adjust it. It's not a big deal. But I want you to start preparing and finishing up the homework, okay, for chapter 8. And let me know if it closes because the dates have been weird. So just keep letting me know. The chapter 8 homework.